Good morning, everyone. I hope I'm audible to you. Am I audible to you and is my screen visible to you? Yeah, great. Thank you very much. So, the next collection which we are going to have a look is the linked list. Is going to be the linked list. Okay. So this is the next question is about the data structure, not about the coding. And it says that you can access the element of the array list in big O of one time. That means big O of one time. What it means is, for example, if you have an array list of one element or 1000 element or 10,000 element, it is going to take the same amount of time to access the contents. Clear? Are you with me? Is my voice clear now? Is my voice clear? Am I audible to you now correctly? How about this now? Is it audible? Okay. Yeah. Thank you very much. So do remember that if I want to access the contents in an array or an array list, okay, we get the best, what you can say, the best data structure to access the contents in order of one. What do you mean by that? Let's take this example. This is actually not a coding question, but a data centric question. Okay. So quickly, I will take you there. So assume that we have an array list with 1 billion elements. Okay. I want to search for a data for a particular Aadhaar number. Okay. So when I want to search for a particular Aadhaar number, what I had to do, I had to go to a particular index and get the data. And I want to get to a particular index and get the data. So the big O of this particular array list is order of 1. That means it is a constant time. It is always going to take that particular time. The data is arranged in a sorted order, and if I want to access that particular element, provided I know the index, what I can do, I can directly go to the index and access it Okay. So this will be dealt in data structure. This will be dealt in data structure. But you should know that since I'm taking a topic of the array list, if someone says what is the advantage of it, tell them that the access time to access a particular element, provided we know the index is order of 1. Okay. So you may ask a question, in which particular situation we shouldn't use array list? Assume that we have an array with 100 elements. Okay. And this is the last index. Okay. Now this particular array list is storing the details of a student, and at the bare minimum what we are doing is we are storing roll number, student name and CGPA. Okay. After admission, after attending some lectures, what the student has done, student has basically dropped out. Student has dropped out for whatever reasons. Okay, let's assume that particular student is at index position 0. So now what has happened is we have to delete these particular records. We have to delete this particular record. So now what happens is the remaining 99 records have to be shifted one location to the left, one location to the left. So this particular shifting of one record to the left is a costly operation, is a costly operation. So normally if there are a lot of insertion and deletion, then we won't be using this particular data structures. If the person whose record has to be deleted is at the end, then there is no issue because then the shifting won't take place. But if it is at some other location, then we need to shift the record. Point number one. Point number two, array, not array actually, array list is a resizing elements. For example, if there are 100 elements, next time when you resize this, it will be doubling that particular size and then resizing it. So whenever it is resized out over there, it may not be in the continuous location. It may be at different location. It may be at different location. That means the next size which is allocated may not be at the continuous location. Okay. So whenever the size of when the array list is full, the size has to be increased. That may not take place in the next adjacent elements. Okay. So do remember that. So point number one, we normally use array list to access the data, which is not changing, which is not changing. In case the data is continuously changing, then we have got something called as a linked list. In case of linked list, what happens is there are two parts. The first part is the info. You'll be learning this in detail in data structure. You'll be creating your own linked list and all these things. But right now, what Java provides is a collection which allows you to directly work with the linked list. But you should be knowing what is a linked list. A linked list consists of two parts. One is the information. Second is a pointer. What does this pointer do? It points to the new location. So assume that one student has taken the admission. So what we do? We add the data over here. Now this particular part right now is not pointing to anything. Second admission takes place. So what will happen? This particular space will be allocated and this particular pointer will be pointing to the next student. So next student data will be stored over here. Now this is not pointing anywhere. When the third student takes admission, this will be pointing to a different location. Now this will have info and so on and so on. Now this particular data which is allocated, okay, is allocated will not be in a continuous location. Wherever it is found, it will allocate it. So this may be at address 1000, this may be at 2000, this may be at 2004, whatever it is, okay, but they won't be in a continuous order. Clear? So whenever we have the data which is continuously changing, what do you mean by changing? There are a lot of insert, update or delete happenings. Okay, then we could use something called as a linked list. For accessing, what we can do, we can store the data in an array list and we could access the data quite fast using something called as a array list. Clear? So linked list has two parts. One is information, another part is a pointer pointing to the next location. Right now it is not pointing anywhere. When the new data is entered, it will be pointing to the next location. This will have the info. This is not pointing anywhere. So now when new data is there, it will be pointing to the new location and so on. It will keep on increasing and so on. It will keep on increasing. So in case we need to access the data in a linked list, it won't be in the order of 1. It will be in the order of n. Do you need to know this? No, we don't need to know this because that will be taught to you in the data structures when we learn about the big O, which we call it as a complexity of the algorithm. Complexity of algorithm. Okay, which algorithm we should use to solve a particular program. Once you have done it, then you have to start which data structures I have to use it. Then once a data structure is clear, then you can decide which particular language we can code in. Whether you want to code it in C++ or Java or Python, whichever language you want. Okay, that's how it works. Right now, what you're doing, you are learning the semantics. You already done this. You're learning the semantics of Java. The next approach will be to learn this and this, okay, in the next semester. Okay, let's go back to our code. So how do I create a linked list? Very simple. What you do is you have a list, you have a linked list, we have a no, yeah, you have array list. Okay, we are using it over here. Okay. So in this case, we are using a linked list and the array list. We are using linked list and the array list. So what we do is we create a linked list, same like how we have created an array list. On the left hand side, we have a list, or you can have a linked list. You have a generic type that is a string. Okay, you have a generic type called a string. You add the data using the add method. You display the contents using directly typing that particular object. If you want to add the element at a particular index, you say that particular object dot add index position and the name. Then you display the contents. Okay, if you want to add the element right at the beginning, this is something new. If you want to add element right at the, which was not there in the array list, if you want to add the element right at the beginning, we have add first. If we want to add the element at the end, we use something called as a add last. Okay, so add last, add first, add will allow us to work with the linked list. Now, look at this particular line. We call it as list string family friends is equal to new array list. So on my left hand side, I have a list generic string, which I am making it point to the array list, which I am making it point to the array list. That means I can have a list which is pointing to array list. I can have a list pointing to a linked list. Okay. So here I have a list which is pointing to an array list, and I use the add method which was used over here along with the linked list also to add the contents in the list. Now we use the add all to add the contents of the family friends to friends. That means I am adding the contents of the array list to the family friends, to the family friends. Okay. So here what I'm doing, I'm adding this to the family friend. So when I say friends dot add all family friends, what is happening? I'm adding the contents of the array list to the friends. Clear? Now, what is the exercise before you start doing is, I want you to go to the Google. I want you to go to the Google, check the collections image, and tell me where is a linked list available. That means linked list is derived from what? So that's a 2-minute activity. Kindly go to the Stack Overflow or internet, okay, and check where we derive linked list from. I'm going I'm going through each and every explanation. Kindly keep on typing it. So, okay. So pay attention, because whenever you'll be working in the organization, the first step is you should know this particular diagram. No one is going to tell you how that is going to work. Since you are a developer, you should be knowing how to take a help from the next. So what will happen is, right at the bottom, we have something called as a linked list. Okay. This linked list is extending which interface? List interface. Okay. Which is derived from collection and which is derived from iterable. Clear? Let me add the code again. Okay. Run this particular code, giving you 2 minutes. Yeah. That's true. Linked list is a class and the list is an interface. Yeah, I made a mistake over here. Linked list implements a list and extends the collection and iterable. Okay. It should have been linked list implements a list, extends the collection, extends the iterable. Have you executed the code so that I can go for the next example? Okay. So in the next example, what I'm doing, I'm creating a linked list of the generic type double. I've added the content. There is something called as a get first. We already know it. Okay. And I'm storing it in a double object. Okay. We know already about the wrapper classes, and I'm displaying the contents over here. So there is something called as a get first, and there is something called as a get last. Okay, if I want to access the element at a particular index, I'll be using get along with the index position. So get first, get last, and get will allow you to work with the particular element. Okay. I hope you have done it. So pay attention. If someone tells you how you can visualize an array list in the memory, you could draw this diagram and tell them that at the index it is 10, sorry, at the index position 0 it is 10, at the index position 1 it is 5, at the index position 2 it is 17, and at the 3 it is 21. Clear? So these elements are stored continuously next to each other. That's why they are blazing fast. Arrays and array lists are fast because it is blazing fast. Sahil, you should know how to display the contents with n number of decimal places now. Kindly figure it out. It has already been taught. Okay, if it hasn't been, then you should be knowing how to take the help and do it. Point number 2. In case this element has to be displayed as a linked list, made a mistake, sorry. Just one moment. The collection says that linked list is maintained as a double linked list. That means this is the information part. This is called the next pointer. And this is called the previous pointer. And there is something called as a head, which is pointing over here. So you may ask, can we also create this? Yes, we are going to learn in the data structures how to declare this head, how to declare this particular class, how to allocate the memory, how to declare the pointers. Are we going to all this in detail? Yes, but that will be a data centric course. But right now, when we say in the linked list, sorry, in the collection I have learned linked list, at the bare minimum, you should know how it is represented in the memory. So we have got some head over here, which is pointing to this particular element. Now, The next element is 5. So this particular pointer is going to point to this particular element with the element 5. It has got the previous pointer which is pointing over here, and it has got a next pointer. Right now it is not pointing anywhere, but when 17 is added, what will happen? You'll get a 17 over here. And for this 17, the previous one is going to point over here. Okay? And the next one is going to point to the next element being added, which is 21. Okay? The previous pointer of 21 should be pointing over here. Clear? So we call this linked list as a double linked list. Why we call it as a double linked list? Because it has got two references or two pointers. Point A is the information part. Point B, it has got a next pointer. Point C, it has got a previous pointer. The previous pointer is going to point to the previous element. The next pointer is going to point to the next element. So this is the memory representation of the double linked list which is there in the collection. Is it clear to you? This is the memory representation. Simple. Linked list is used whenever we need to add, update or delete. For example, if I have to delete this particular element, then no need to shift. What I'm going to do? I'm going to make this 10 point over here. This 17 previous pointer is going to point over here. That's it. No need to shift any elements. Understood? Clear? So whenever you have to do the addition, updation or deletion, kindly use a linked list. These are nothing but the pointers. Each linked list will be broken into three parts. One, to hold the data. One, additional space for storing the pointing to the previous location. Next pointer to point to the next location. That means the next element. Will it take space? Yes, definitely it is going to take space. So this particular linked list is going to take more space than the array list. Questions? The moment I say I need to add one more element, so internally what will happen? It will allocate the space for the previous, it will allocate the space for the next, it will allocate the space for the information. So this will be the total space of the linked list node. And then what will happen is this particular guy will point over here, this one's previous will point over here, and so on. Linked list is never used to access the data. No. For that, this is much better. Why? Because the array elements are stored next to each other. But in case we want to delete a particular element, for example, if we want to delete this, then it's a big problem for me because this is 10. Now what I have to do? I have to shift 17 over here. So 17 has to come. Then this has to come over here. 21 has to come over here. That's a big no in terms of performance. Yes. So what happens is whenever you are doing a particular project, okay, there'll be the project requirements. The project requirements will be decided by the project manager in terms of what should be the space complexity, what should be the time complexity, and what is the use case. Are we going to access the data only, okay, such as your attendance? Yes. Now from the faculty perspective, I have to continuously keep on adding or I have to continuously keep on modifying, such as your stock exchange. So in that case, I won't be using array list. I'll be using something called as a linked list out over there. This is just two cases I'm giving. Actually, there are many more. There is something called as a binary tree. There is something called as a hashing. Okay, but that will be dealt in the data structure. So what I'm trying to tell you is, whenever a question is asked in the interview, it will always be the algorithmic question. Point number one, always remember, whether you are going for the interview for the Microsoft or whether you are going for the Infosys. The first question is whether you know an algorithm to solve it. If you know the algorithm, then which data structure? Once a data structure is clear, you should be in a position to write the code. If you are in a position to write a code, yes, you know the subject well. Any further questions? Wherever there has to be addition or updation, we could use a linked list. I can take a data from the array list, put it in the linked list, and then I can keep on modifying the data. You have a data in the mobile. You want to search a data. What kind of an algorithm it will use? You have Google Map. What kind of algorithm the Google Map is using? If you want to take academic question, then assume that there is an array list. I want to find a duplicate element. So which algorithm you are going to use it? Right now you are exposed to only one algorithm, and that is a brute force. What do you mean by brute force? Let's take this example. Let's say we have the contents 1, 2, 3, 4, 5, 6, 7, 5. Okay. So these are the contents of an array given to you. These are the contents of an array given to you. Clear? Now the question is, okay. Now the question is, how you are going to find a duplicate element? So write some thoughts what you are going to do. This is an array given to you and you have to check whether it contains a duplicate element or not. Which is the element which is duplicate? Only one element will be duplicate. So how you are going to do about it? Okay. So as a first year student, engineering graduate, he is going to say, I'm going to use a loop. Okay. Then I'm going to check with this particular element. Okay. Whether this one is available over here, and so on. Right. Then I'm going to start with 2. Okay. Then I'm going to check whether it is available here. Then I'm going to do with 3 and I'm going to check it. Then for the 4, I'm going to check the remaining element. Then for the 5, I'm going to check for the remaining element. Yes or no? Right? What if the data is not sorted? For example, assume that it is something like this. 5, 1, 2, 3, 5, 4, 6, 7. If this is the case, then what I'm going to do, I'm going to start from here and do the comparison over here, right? Understood? But if the duplicate element is the last element 7 and the 7, then what I will have to do, I will have to start from here, do the necessary comparison. Then I will have to start from here, do the comparison. So if the last element is a duplicate, then what is going to happen? It is going to take a long time. It is going to take a long time. So that's how the first year students are going to answer it. Okay? Okay? So what will be the complexity of it? How many loops you will be needing? You will be needing 2 loops. Yes or no? You will be needing 2 loops. For, within, for. Okay. So when we have the for within for, what will be the complexity of it? It will be for n square. Okay, n square. Right? Now from the data center, let's assume you are in the third year, you are sitting for the placement. So this kind of a solution or this kind of an approach won't work. You may start with this particular approach, but then the person who is going to take an interview is going to say, can you improve this particular logic? So what I'm going to do is, I'm going to create another array. I'm going to create another array. Okay. In this particular array, what I'm going to do, I'm going to put a element at a particular index. Okay. So this is at the 0th index, this is at the 1 index, this is at the 2nd index, this is at the 3rd index, and so on. Okay. So let's assume 1. Is it available over here? It's not available over here. So let's increment it. It becomes 1. Is 2 available over here? It's 2 is not available over here. So let's make it so on. When this particular element is there, what will happen? I will check this. Is the element here? Yes, the element is here. Okay. So what will happen? I will increment this index. So the index now becomes 2. The moment I find the index is 2, what will happen? We should stop over there. Right? We should stop over there. We call this as a frequency counter. We call it as a frequency counter. If you are not in a position to relate to it, perfectly fine, because it will be taught to you in the data center, in the data structure part and algorithmic part. Okay. So, but remember that this is how you will be going in the third year and the second year. Now there is something called as a frequency counter. In the frequency counter, what I do, I create another array. Okay. In this array, what I do, I store the frequency of each and every element. Since my question says that only one element is appearing twice, whichever index has got the index as 2, that will be the duplicate element. Okay. So now the next step is the interviewer going to ask is, what is the space complexity of it? Okay. Point number 1, this is the original array, and this is one more array you have taken. Okay. This is one more array you have taken. So now what has happened? You have taken the space complexity. You have increased the space complexity. Okay. Now why these are very, very important is because in the real life, okay, you are always going to work with the data which is in the billion, and a poorly written algorithm can bring even the fastest computer down. Assume that the programmers at the Aadhaar card have written the code for searching in this particular way, that okay, this Aadhaar number is there, kindly go and check the billion records. It's not there, then start from here. Now this should be checked with the billion record. Okay. If this was the logic written in the Aadhaar card, then if you give the search command today, kindly check how much time it is going to take. For example, if it is going to take 1 second, one instruction per 1 second, then it is going to run 1 billion into 1 billion time. Okay. It may take eternity to complete it. So algorithms are very, 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 very important. Clear? So then the interviewer says, okay, fine. You have taken an additional array. I do not want to take an additional array. So what I should do? There is something called as a two-pointer approach. One pointer is going 1 step ahead. Second pointer is going 2 steps ahead. Clear? So once you give this particular approach, at that time the interviewer will know that yes, you know the algorithm to work on it. Now you write a program and then the next question will start. Okay. So that is called the algorithmic approach. So you may ask how much time it basically takes for the student to get comfortable with it. As soon as you complete this particular semester, you could start the journey with us. Okay. It may take around 6 plus 6 plus 6. It may take around 18 months to get comfortable with this particular technique. After solving around 400 questions, you may be comfortable in having this particular approach. Is it clear? That means by the 5th semester, you should be comfortable. I hope I had just given you what are the main things being asked by the interviewer in terms of CSC. Can we go back to a program now? Or you have any other question? The moment you use any predefined method, they are going to ask for the complexity of it. Okay? Manirup, the question is not about how much you know about the language. The question is, what is the algorithmic approach you are going to take to solve the problem? Because you will be always working in a team. And that team may contain some IIT students, some BIT students, some XYZ student. So main thing is whether you can fit into behavior into that particular team or not. No, I'm not going to explain this because this will be explained when we have the data, when we are doing the data structure codes. Predefined functions are always faster, yes. But then you should be knowing the complexity of it. What if the interviewer asks you cannot use the predefined function? Then what are you going to do? So always and always the questions will be related to algorithm, then data structure, then language, then implementation. And if any of the steps you fail, then you're gone. You're gone means you fail the interview. This collection is always and always faster. If you're looking for C++, STL will be faster. Collection in Python will be faster. In terms of language performance, C is fast, C++ is fast. Then Java will be slow, Python will be a little bit more slow. Why these performance are important is there is always one or two student. Again, Vishal, I'm telling you, it's a data set. It's a data structure. There is no point in me teaching you how to solve the question using two pointer because you should know where to put this two pointer into, in which algorithm you should put. So in algorithm, we always start with the brute force, then we break it into the various algorithm, and then how we put a data structure. That's why there is no point in me telling you what is a two pointer structure. In case, but if you want to know, it is something like we have got two pointers. One pointer will move one step ahead, second pointer will move two step ahead. When they two meet, you have found a duplicate. Then you have to go to that particular index, pick up the element. Any further questions? Any other generic question you have? Can we go back to collection now? There is an important saying. There is an important saying. Okay. In the second year, as soon as you start data structures, okay, you start practicing it vigorously. Because once you start your journey from the second year in data structures, by the time the fifth semester is over, you'll be comfortable and you should be in a position to crack it. Clear? At that time, we won't be explaining the language semantics. Okay. At that time, we won't be teaching you the language semantics. That means if you had taught you Python and Java, okay, and in the company, if you say we want to do it in C++, you may be given 3 or 4 days to learn C++ because both of them are object-oriented programming language. So you will be given one particular link for the tutorials. You can go through that particular tutorials and you should make yourself comfortable. Or at the most 1 or 2 days of training will be given and you will have to write that particular code. Well, when the third semester will start, once the final exam is over and the third semester will start, at that time you will be told the various subjects. What are the various subjects of the third semester and when it will be, whether it will be online or offline. Depends upon the situation which is available at that time. Right now, what you should do, you should practice in Python and Java. Okay? When your second semester will end, at that time it will be told to you. A notice will come from Sushil sir regarding the date and time when it is going to start. Okay, let's go back to our coding. So now you must have realized that these are the very, very easy. This is not at all challenging. Why? Because we are only learning the grammar of the language. Okay, so this particular semester till May, June, whatever is the time given to you, you should be making this Python and Java strong. Because once your third semester start with data structures and algorithm, we won't be going back to the language. Okay. So what I did in the next example, I created programming languages of the type linked list. Generic type is string. These are some of the languages. Okay. And we are using a predefined method called as remove first, remove last. And what I'm doing over here, I'm trying to remove an element. If it is removed, then it should display the programming languages. Okay. There is something called as a starts with, which is going to check whether this particular programming languages have got something which starts with C, then it should display it. Clear is going to remove all the elements from the linked list. Okay. What if I want to search the element? Okay. If you want to search a particular element, it provides something called as a index of and the last index of. Index of will find the first occurrence, last Occurrence, if you want to search, then we'll use last index of. Once you are done, kindly type a message done so that I can go for the next example. Thank you, Sahil. Thank you, Akriti. Okay. Thank you, Nikhil. Okay. Let's see. If you look at the beauty of the collections, once we know how the iterator works, it will work the same for whether it's a linked list, array list, or stack, whatever it is going to work the same. So now if someone tells you kindly use the iterator to display the contents of the linked list, you know what to do it. You declare an iterator, okay? Use a generic data type. In this case, it's a string, so you will be using string. And basically point it to the element for which we have created an object. We have created an object of the type linked list. So make it point to it by using a iterator method. And now we know which method we have to use. We have to use a has next and next method. Are there some methods specific to this particular linked list? Yes. We could use something called as a descending iterator. Okay. So what we have done, we have used the iterator pointing to the string and it is pointing to an object of the linked list. And here I am using descending iterator. Here I am using descending iterator. So what I can do, I can do it in a descending order by using this particular descending iterator. The method names are going to be the same. It is going to be has next and next. You may ask, can I use a list iterator? Yes, you can use a list iterator over here. What I do over here, I create a object of a list iterator, okay, and I can make it point to this particular object called as h using list iterator, and we can use a size operator over here, and we can use has previous and previous. So whatever you learnt in the list iterator can be also applied over here. Can also be applied over here. As a name describe descending iterator, ascending, descending. Kindly figure it out what it does. as the name suggests, descending. Once you run the code, then I'll ask you the next question. So now my first question to you is point number 1. Is descending iterator available only for the linked list? Is it available for array list also? So I want you to go to the documentation and check it out. Where is this descending iterator available? Is it available in the linked list? Can it be used by array list? So kindly use a documentation, check it out and tell me. And then you can type the responses. Okay, I'm getting some information. Yes, yes. Java.util.linklist. Linked list only. Wonderful. Good. Okay. Yes, thank you very much, everyone. Good. Wonderful. So if you know how to use a documentation to go through the various methods, yes, you are going in the right direction. Yes, Sahil, I've gone through your explanation. Wonderful. Good. So in the collection, we have got something called as a stack, which is we have got something called as a stack. What do you mean by stack? Last in, first out. If you have stayed in the hostel, so whenever you have a lunch or dinner, there are stack of plates, or there in the library we have stack of books. Yes or no? where the books are kept on top of each other. You normally will pick up the book which is at the top. That's how the axis is. Clear? In terms of function, whenever you have written many functions, the functions are called from one to another, then what will happen? They will be pushed in the stack. Let me explain this for you. Let's assume in any a particular language, let's take any generic language. Okay, there is a function called as main, which is making a call to A function. A is in turn making a call to B. B in turn is making a call to C. Once the C is executed, it should go back to B. B should be executed to A. A should be going back to the main. So what happens is, whenever the function execution will start, the address of main will be pushed over here. So I'm writing it over here. Main makes a call to the A, so the address of A will be pushed over here. A is making a call to the B, so that address will pushed over here. B is making a call to C, so that address will pushed over here. Once the C execution, this particular line of code, assume that these are the lines of code. Execution is over, what will happen? C will die. That means what will happen? This will be removed from the stack. Then what happens? This particular thing will go to B. Once the B execution is over, what will happen? B will die. So what will happen? B will be removed from this particular stack. Then it will come to A because B was called from A. So then what will happen? The execution of A will start. Then A will be removed. So this will be removed. Okay, once main execution is over, main will be removed. The program will be removed from the memory. And what will happen? Main will also be removed from the stack. Okay, so whenever there is an execution of the code, what we do, we use something, execution of a code using a function. Then what will happen? It is always going to use something called as a stack. Remember that. So if you look at the diagram, stack is extending a vector. Vector is implementing a list. List is extending a collection. Collection is extending a iterable. Iterable, collection and list are the interfaces, and the concrete implementation are vector and stack. Okay. So what we are learning? We are learning something about the stack. So similar to your, and what does the stack has? Stack has got something called as a push operation and the pop operation. Push means what? We'll keep on pushing the elements. Pop means we can't basically remove the element at any arbitrary position. For example, I cannot remove this element. I'll be always going from the top. I'll be always going from the top. Elements are added and removed from the top. Elements are added and removed from the top. The top element is this one, the stack top. So what I had done, I had declared a stack over here. My object is called a stack of cards, which is of the type string. I've added the various elements over here. I display the contents. Then I learned the methods such as pop. Now what does pop do? Pop is going to remove the topmost element. Okay. So in our case, which is the topmost element? I have added jack, then queen, then king, then ace. So this is the topmost element. That particular element which is removed is stored over here, and then I display it over here. Now if I display the current stack over here, the stack of cards should have jack, queen and king. Okay. Previously ace was at the beginning, at the top. It has been removed. So now if I have a top, if I have a pop over here, then what will happen? King will be removed. Again, if I use a pop, then queen will be removed. If I use a pop, jack will be removed. If I use a pop again, then what will happen? You will get an error because the stack is already empty. The stack is already empty. So how we add the elements in the linked list? We say add. How do I add the element in the stack? Using push. Corresponding to push, what I have a pop. What does pop do? It removes the topmost element. Once the topmost element has been removed and displayed, how I can display the remaining stack? Simply say stack of cards. So what should stack of cards should display? Jack, queen and king. Again, if I use a peak, now kindly remember there is a difference between pop and peak. Peak means only have a peak at the topmost element. Which is the topmost element? King. So it should display king. But if I display the stack of cards, it will still display jack, queen and king. So you may ask, what is the difference between pop and peak? Pop will remove the topmost element. Peak will only have a peak at it. It won't remove it. It won't remove it. Clear? Peak will always show the topmost element. Difference, peak and pop both will show the topmost element, but peak is going to display only the topmost element. It is not going to remove that. Pop will remove that element. So I have a stack. I say push A. So what will happen? It will push A. Then I say push B. So it will say B. Then I will say push C. Then I will say push D. Okay. Now if I try to display the contents of the stack, it is going to show D, C, B, A. Then I use a pop method. What does pop method do? Pop method will remove this element. So when I remove this particular element, what will be the contents of this particular stack C, B, A? Now I use a peak method. So when I use a peak method, what it is going to show me? It is going to show me the topmost element, which is C. And what will be the contents of the particular stack? It is going to be C, B, A. Are you with me? Instead of peak, if I use a pop, then what will happen? The topmost element is C, but the contents of the stack will be B and A. That's what I said. Pop will display the topmost element and will display the stack. Whereas in case of peak, it will only display the topmost element, but it won't basically affect the stack. It won't remove the contents. So all the students kindly pay attention. When we start data structures and algorithm, we'll be doing n number of coding questions on the linked list, where you'll be creating your own linked list and we'll be using the optimize method as well as the brute force method. So whenever in the data structures, assume that after learning the complexity, let's assume that we are learning the linked list. So we are going to write your own linked list, plus we are going to use your own collection. Then what we are going to do, we are going to solve the questions based on the algorithms. Okay, so a question A, question B, question C will be asked. So what we'll be learning in the next particular semester, maybe the third as well as the fourth semester, is whenever a question is asked, whether it's a plain question or scenario question, how to put it in a particular algorithm. Okay, whether all the three whether all the three algorithms are right, yes, all the three algorithms may be right, but then depending upon the complexity, because we already know what is the questions being asked by the interviewers. So some interview will ask you about the space complexity, some may ask you about the time complexity. Okay, so based on that, we'll be removing certain algorithms, then we'll be writing the optimized code. So this is going to take a long time. Okay, so this is going to take a long time. Right now, we are not concentrating on the holidays or all this question, because right now what you have to do, you have to complete this particular semester, okay, give the final end term exams. So when your final end term exams will be conducted, at that time, everything will be clear to you. see, this is the syllabus. Okay, this is the syllabus available for this. We have done array list, we have done a linked list. Then there is going to be an overview of the queue set. Okay, so we have to basically discuss the queue and set, what it is, as well as the overview of the map. Then there'll be overview of comparable and comparator. Nowadays, we don't use vector because it is not thread safe. So after that, we have got a file handling and we have got a JDBC. That means how we can connect to the JDBC. So after this entire syllabus is over, then the map will be shown to you. Okay, what are the questions you can solve from CodeChef, from the HackerRank, HackerEarth, and so on. So that depending upon your programming capabilities and your hard works, you can utilize that particular path. There is no point in me telling you right now before completing this particular syllabus. So allow me to complete the syllabus first, then I will tell you the path. Then you can, depending upon your interest, you can devote 2 hours, 4 hours, 6 hours to solve those particular examples. And those who want to participate in this, I'll be basically taking your tracking system, in the sense, in a week, how much you have done. Normally, any coding context, all of you please pay attention, throughout India, throughout the world. Normally, whenever you are participating in a hackathon or you are participating in a, what you can say, HackerRank, any event I'm talking about, for example, it is a college event, each and every event will be based on algorithms and data structures. There is no point in asking the students to write a brute force of code. Okay, because writing a brute force is not coding. Coding is all about deciding an algorithm, thinking about a data structures, and then writing the code. So all 99% of this will be based on whether you know data structures and algorithm. But yes, as soon as our JDBC input output is over, I'll be taking a session. Which are the questions, which is the first step questions you should be solving, so that it gives you advantages over other students, other college student. Where you should start from, which are the questions you should solve, and how you should be sharing me your points, how you should be sharing me your points. In a week, we have done so many things. So where you should start? You should start from HackerRank, HackerEarth. Which kind of questions we solve? Which are the questions we don't require algorithm? Which are the questions we simply check your coding skills and so on without algorithm? But that will be possible only after I complete this particular JDBC syllabus. Okay. Right now, your maths has to get over, right? Your maths syllabus is going on. When is your end term exam? Do you have some exam tomorrow on maths or any other subject? Because Saturdays are normally reserved for exams, I guess. Okay. No exams tomorrow? Okay. Then tomorrow at 10:45. At 10:45, we'll meet again where I'll be telling you which coding samples you should start. Those who are interested in coding should join. Those who are interested in coding, those who want to basically see themselves in good company, or those who simply want to improve their coding skills with the test cases, I'll tell you the coding samples. I will provide you the timeline also, because now what has happened is, I guess next week you have some exams on physics. So many exams you have, right? Maths exam, your end term of the maths will be coming. Why you have any class before 11 o'clock, Ankit? So tomorrow we'll be joining at 10:45. Let's continue with our collection with stack. Uh, so have you executed that particular code of the stack? Have I have I given you that particular code? Okay, sorry. Let's continue. So next, what I done, I created again the stack of cards of the type string. I'm checking whether it is empty or not using something called as isEmpty. Now, where we'll be using isEmpty? You already know that you can use a pop to pop the element, right? If you now, for example, if I use a pop, jack will be removed. If I use a pop, again queen, then king, then ace. Again, if I use a pop, then what will happen? It will throw an exception. So before using the pop, it is good idea that you should use isEmpty to check whether the stack is empty or not. If it is not empty, then only use the pop option. Then this will give me the size of it. Okay. Then here what I'm doing, this is a very good function. This is a very good function. We are using something called as a search, which is going to search for this particular element, and it is going to give me the position. If it is -1, it means that particular element is not there in the stacks. If someone asks you how we can search for the particular element in the stack, tell them that there is a search method that is going to search for it. Okay, there is going to search for it. -1 indicates that that particular element is not there. That particular element is not there. Along with that, we could use isEmpty. isEmpty is used with the pop operation. Before we use the pop operation, check whether it is empty or not. If it is empty, then pop shouldn't be executed. If we use a pop, then what it will do? It will give me the exception. isEmpty is indirectly going to check the size of it. Okay. The next concept, as usual, we'll be applying the iterator on this particular plates of iterator. We'll be using a has next and next to display the contents. For each loop and reactive programming in Java, we haven't learned. We'll be learning in advanced Java. So at that time, I'll be teaching you many shortcuts or the new methods of using the Java, such as Lambda and parallel streams, which are related to collections. That makes Java coding really a fun. Is it there in Python? Yes, it is also there in Python. If you want to use the backward, if you want to display the contents in the backward order, then I'm relying on list iterator. Then I'm relying on list iterator. Kindly pay attention. This particular part I haven't taught you. It belongs to Lambda because this arrow operator is called a Lambda. Okay. But I'm giving you the code, so don't worry about it. You're going to have a separate sessions for the Lambda. Comes under advanced Java. Okay. So kindly pay attention. Tomorrow's session will be for the code enthusiastic who wants to use Geek for Geeks, HackerRank, HackerEarth. You might be confused which question we should solve. You might be want to check what is your standard in a class of 330. You just want to check what is your all India ranking. All this basically coding practice will start from tomorrow. Okay. So tomorrow's session will be exclusively for that, in which kindly pay attention. Since that session is going to be the coding, you could write the code in Java or Python or any other language you're comfortable with. What I'm going to give you is I'm going to give you the path you should follow for improving your code. See, any of this platform without a data structures and algorithm knowledge will not help you. You may say that I have solved 400, 500 questions. Okay. You may have a CGP of 9.5 or 10. But if you don't know where to classify the program according to the algorithm and come for that particular solution, then it's of no use. It's of no use. So platform really doesn't matter. Platform really doesn't matter. What matters is when the interviewer or the coding test is there, okay, how you are in a position to select that particular question according to the algorithm and write the code. Why 90% of the students are not in a position to get into 95 or 98% are not in a position to get into the Amazon or Flipkart? Because their test cases can be solved only if you know only no. Kindly pay attention. A student who is very good in data structures and algorithm may have solved only 100 questions. They will be in a position to crack the code. A student without a knowledge of data structures and algorithm, even though mechanically they have solved 500 questions, will not be good. So I'm directly telling you the correlation. 400 was just a baseline given after the knowledge of data structures and algorithm. Are you with me? Are you with me? So point number one, Point number one, let me make this very, very clear because you shouldn't be mistaking it. The path which I'm going to tell you tomorrow will be for pure coding improvement. It won't be a DSA path or the algorithm path because that haven't taught you. It is simply to improve your coding and check whether your coding is in a position to solve those test cases or not. I won't be giving you the questions based on DSA. No. Once the third semester your DSA start, we'll be taking some examples and then we'll be exposing you to the online platform where you should be solving the questions related to the DSA. Once it has been done, yes, then you should be participating in a hackathons. That's the way you should go about it. So 400, 500, 200, 100 doesn't have any answers. I'm just telling you, write the code so that you get a hang of it. Okay? Yes, I was in a position to solve it in how much time? Some may be taking 1 hour, some may take only 15 minutes. That depends upon this coding. Whichever language, see, this is not a test. This is something you should be in a position to crack at the exam. Normally, companies will open C++, Java, okay, along with the Python. So you are free to use any of the languages. Most probably data ST and algorithms may be in Java or maybe in Python. Most probably it will be in Java. But whenever we have taught you data structure and algorithm, if we taught you in Java, you should be in a position to write the code in Python because we already learned Python. Any other questions? Okay. So kindly pay attention. Tomorrow's session will be only telling you about how we should improve the coding using the various platform. Monday, we are going to continue with our coding examples on the next topic, which is Q, along with some coding practice of linked list stacks. Okay. So that will be the end of the session. Thank you very much. The recordings and the lecture notes are already uploaded.